The last part of chapter 3 is going to switch from quadratics into rational. So we're going to be solving rational equations. And then chapter 4 will take this further and do rational inequalities. But a rational equation is anything that is an equation involving rational expressions, which is a bad definition if you don't know what the word rational means. So rational is anything that is a fraction. So a rational number is any number that can be written as a fraction that is repeating and terminating decimals. So a rational expression is a fraction with two expressions. So something like a p of x over a q of x. I like to think of it as soon as you put an x in a denominator, you're talking about something being rational. Then if you put an equal sign in it, you're talking about a rational equation. To solve a rational equation, hopefully you've actually done this before in its review, but there's two methods of doing it. One is what we call the destruction method, which is generally the most common method. And then the second is the creation method, which is the way that it's a bit safer because you can do it anytime. Like you can always create a common denominator and add and subtract fractions, whereas destruction is something that's very specific to an equation. And then there's one more thing to be aware of when you're solving a rational equation, which is that every time you solve a rational equation, you have to say that all of the results are possible. The reason they're possible is that for something where there's an x in a denominator, there's things that x cannot be. So you always have to check to make sure that what you've solved for isn't something that makes your equation undefined. And we'll practice that as we go through. So we're going to go through an example of solving this rational equation, and I've kind of written down steps for how to do it, and then we're going to practice some from scratch and on our own. So the first thing is you have to have an equation that's rational. So how do I recognize that this is a rational equation? Well, A, there's an equal sign, and B, there's an x in the denominator. To solve a rational equation, the first thing that you're going to do is factor. Now, I tend to only factor the denominators with these and not the numerators, which I'll show you why in a couple examples. Then, once you have your denominator factored, so I recognize that this was a difference of squares, so I factored it to x minus 2, x plus 2. Then what you want to do is figure out what's the lowest common denominator. So the lowest common denominator is always, especially when there's expressions, just everything multiplied together. So my lowest common denominator will be x minus 2, x plus 2. Then you want to set your domain restrictions. So your domain restrictions for this one is that because my denominator is x minus 2, x plus 2, x cannot equal negative 2 or 2. And that's because if I put a negative 2 in here, negative 2 plus 2 is 0. Anything divided by 0 is undefined. And same thing with the plus 2. This is set notation. I prefer set notation for these, but our textbook seems to love interval notation. So you could also say that the domain is that x cannot equal negative 2 and 2, meaning it can be everything from, negative infinity to negative 2, negative 2 to 0, or to 2, and then 2 to positive infinity. All right. The next thing we're going to do is solve. And to solve, what we're going to do is get rid of our denominator. It's the thing that makes it tricky. Right? We know how to solve a linear equation, we know how to solve a quadratic equation, but rational equations we don't know. So this is where you get your choice. You're going to choose either destruction or creation. Solving using destruction is that you want to destroy all the denominators. And the way that we do this is we use the rule that what's it called? The multiplicative property of equality or something fancy like that. But it's that you're allowed to multiply by whatever you want as long as every single thing in an equation gets multiplied by that same thing. So it stays equal. So if my lowest common denominator is x minus 2, x plus 2, that means that if I multiply every term in the equation by x minus 2, x plus 2, I'll be able to simplify all the denominators. In other words, here, x plus 2 divided by x plus 2 is 1, which makes it go away. X minus 2 divided by x minus 2 is 1, which makes it go away. And for this one, you're getting rid of both of them. So what you'd be left with is x times x minus 2 minus 1 times x plus 2 is equal to 8. So that's the destruction method of getting rid of these rational denominators. The next method we're going to look at is called creation. And it's got a very similar result we're still going to get here, but instead of multiplying everything by something, we're going to create a lowest common denominator. So if the lowest common denominator is x plus 2, x minus 2, or x minus 2, x plus 2, this term is missing the x minus 2. So I can multiply top and bottom by x minus 2 because I'm really just multiplying by 1. This term is missing the x plus 2, so I'm going to multiply by x plus 2 divided by x plus 2, and then this term is missing nothing. That will leave me with x times the x minus 2 all over x minus 2x plus 2 minus the 1 times x plus 2 all over the x minus 2x plus 2 is equal to 8 over the x minus 2x plus 2. And then you'll notice I've crossed out the denominator for a couple of reasons. Number one, you could think of it as destruction. I could now multiply everything by x minus 2x plus 2 and destroy all the denominators. Or you could say, hey, you know what? That's already equal. I'm trying to find something that makes left side equal to right side. Well, the denominators are already equal. I don't need to worry about them anymore. I need to figure out what's going to make the numerators equal. So I've got x times x minus 2, negative 1 times x plus 2 is equal to 8. So it didn't matter whether I did destruction or creation. I ended up at this same step. Then the next thing you're going to do is simplify what you've got left. So here I'm going to distribute the x, here I'm going to distribute the negative 1, and then I'm going to see what I've got. I've got x squared minus 2x minus x minus 2 equals 8, which I can recognize as a quadratic equation. Once I recognize it's quadratic, I know that to solve it, I'm going to make it equal to 0. And then I'm going to solve by factoring, square root method, completing the square, or quadratic formula. Now I find, I think 100% of the ones in this course, when you get to this point, they are, I shouldn't say 100%, some will, most will be factorable. So I'm going to look for two numbers that multiply to give me negative 10 and add to give me negative 5, which is negative 3, which is negative 5 and positive 2. So this would factor to x minus 5, x plus 2. And then I solve each of those factors. So x minus 5 equals 0 when x equals 5, and x plus 2 equals 0 when x equals negative 2. Then you have to check. So I stop putting this for 5. In this fifth step, this is where I have my possible solutions. These could be things that make my original equation true. Now to check it, you have two choices. Number one, the best way would be to actually take this number 5 and put it into the original equation and make sure that it makes it true. So if I was to do that, I'm just going to shrink down my screen, I'd have 5 over 5 plus 2 minus 1 over 5 minus 2. Does that equal 8 over 5 squared minus 4? Now I'm not going to do some big laborious check. I'm literally going to plug it into my calculator. So I'm going to plug in 5 divided by 7 minus 1 divided by 3, and I get this awful decimal. Okay, I get 0.3809 ... But when I go to plug in the other side, which is 8 divided by 25 minus 4, which is 21, I get that exact same decimal. So that answer is good. That's going to be a true solution to the question. If I go to plug in negative 2, there's two things that would stop me from doing that. Number one is that I knew that in my domain I said that x couldn't equal negative 2 or 2, so I could just stop right there. Or when I go to plug it in, I get negative 2 over negative 2 plus 2 minus 1 over negative 2 minus 2 equal to 8 over negative 2 squared minus 4. And here there's two places that make my fraction undefined. This first one, negative 2 plus 2, and then here, 4 minus 4. It's going to make my denominators equal to 0. So in a way, it's true, like left side equals right side. Left side is undefined, right side is undefined, but that's not actually a solution because it's undefined. So we reject the negative 2 and say not a solution, and then we say that the only solution to this equation would be 5. So I've written some steps out here. I've realized I misnumbered them here, but when we go to solve a rational equation, first thing I would do is A, recognize it's irrational. Then I would, number one, factor, find the lowest common denominator, determine the domain, solve using or get rid of the fractions by using either destruction or creation, simplify, then solve the either quadratic or linear equation that you get as a result. And then lastly, what you get from there are always possible solutions. So you want to check them and make sure that what you get is actually a solution. So let's try to go through these 8 ish steps and solve another one. So here's a question. I'm going to zoom back in. Okay, first thing I do is recognize that it's rational. Yep, there's an x in the denominator, which means I want to get rid of it. So the next thing I'm going to do is figure out, well, what's my lowest common denominator? Well, everything else is over 1. So my lowest common denominator is x, which would tell me that x cannot equal 0. And again, I'm super fine with set notation, but you could say, oops, not a squiggly bracket. You could say x is everything from negative infinity to 0, and then from 0 to infinity, if you love interval notation like our textbook. Then you have two choices. You can create that common denominator of x, which means you'd multiply this one by x over x and this one by x over x so that you have that thing in common and you can get rid of it. Or, like most people do, we're going to solve using destruction. So I'm going to take that lowest common denominator and I'm going to multiply every term in the equation by x. I'm going to be left with x times x is x squared. And then here, the whole point was to destroy that denominator, and I'm left with a minus 12. And then 1 times x is x. Then you have to ask yourself, what type of equation am I left with? It's no longer rational, and it's either going to be quadratic or linear. Because the highest exponent is 2, it's a quadratic. To solve it, I'm going to make it equal to 0. And then I'm going to use one of my methods. So factoring, square root method, completing the square, or quadratic formula. But like I said, most of these are factorable, if not all. So two numbers that multiply to give me negative 12 and add to give me negative 1 are negative 4 and positive 3. So my two brackets would be x minus 4, x plus 3. Then I'm going to solve. What makes x minus 4 equal to 0? Add 4 to each side. I get x is 4. What makes x plus 3 equal to 0? Minus 3 from each side. X equals negative 3. Now I said that my restriction was that x couldn't equal 0, which means that both of these solutions are fine. And that would be my answer. All right, if you want to know for sure, you could plug these into the original equation and make sure they make it true. But generally, as long as you didn't mess up, then these answers you get should be good. Like either what's going to happen is they get rejected because they don't match the domain restriction, or they're going to be good. It's not like you're going to get an answer that you're like, oh, but it didn't make it true. If that happened, you just made a mistake somewhere and you've got to figure that out. All right, moving on to the next one. So, step number 1, is this a rational equation? Yes, there is a variable in the denominator. Step number 2, we're going to factor the denominator. Now, I skipped that step with this one because I didn't need to do it. Whereas this one, when I look at the denominator, you know, I've got this m plus 2 and an m squared minus 4. Hopefully you're looking at this and thinking, ooh, difference of squares. So let's start with that. We've got 3 over m plus 2 plus 1 equals 4m minus 4. I do not factor my numerator. I find if you factor your numerator in a rational equation, it's a waste of time because you end up having to multiply back through. So just leave it. My denominator will factor to m minus 2, m plus 2. All right, then I figure out what's my lowest common denominator. Well, it's going to be that m minus 2, m plus 2. Then you've got two choices. Multiply every term by m minus 2, m plus 2, or create that common denominator of m minus 2, m plus 2. Totally up to you. I also always forget the domain restriction. M cannot equal plus or minus 2. As long as you do it at some point, I often forget until I'm done solving, and then I'm like, oh yeah, right, what can m not be? But regardless, so I'm going to do destruction because again, that's the one I find most people have a tendency to want to do. Although I do like, personally, I'm a bit of a creator. I just create and destroy at the same time. So find your own path. Awesome. So the whole reason we do this is so that we can destroy the denominator. So m plus 2 divided by m plus 2 is 1. M minus 2 divided by m minus 2 is 1. What am I left with? Well, I'm left with 3 times the m minus 2 plus a 1 times an m minus 2 and an m plus 2. And then over here, I didn't continue scratching out. And over here, I'm left with a 4m minus 4. So step 1, recognize. Step 2, factor. Step 3, find the lowest common denominator. Step 4, state your restrictions. Step number 5, I think I'm giving these different numbers, but it doesn't really matter. Either create or destroy, and then simplify. So I'm going to multiply the 3 through. And then 1 isn't going to do anything, so I'm just going to multiply these. Now I know those are complements or conjugates, so I know it's just going to be m squared minus 4. If you want to put in more work, like m times m is m squared, m times 2 is 2m, minus 2m. Oh, look, they went away. And then negative 2 times 4, or 2 is negative 4, that's totally fine. But I take advantage of it being math 60 and not writing it. Then I have to recognize what type of equation am I left with? Well, I have a squared, so I'm thinking this is going to be quadratic. So I'm going to simplify a little bit further. I'm going to get m squared plus 3m minus 10 is equal to 4m minus 4, and then I'm going to make it equal to 0. So I'm going to minus the 4m, and I'm going to add the 4. That's going to leave me with m squared minus m minus 6 is equal to 0. It's a bit of a trend here. Then I'm going to factor this. Two numbers that multiply to give me negative 6 and add to give me negative 1 are negative 3 and positive 2. And then I'm going to solve. This is going to give me m equals 3. This one's going to give me m equals negative 2. Then I'm going to check against my domain restrictions. M cannot equal negative 2 or positive 2, so this is not an answer. And I would say that my only answer is 3. And if I wanted to make for surely sure, I could just plug it into the original equation and make sure that left side does in fact equal right side. All right, how you feeling about this? If you're feeling good, pause the video. Give this one a try on your own. If you're still feeling a bit nervous, feel free to keep watching. So, rational equation. Step number 1, factor. I notice in the denominator of this guy, I have a greatest common factor of y, and I'm left with y plus 5. The rest of them are fine. Then I figure out what's my lowest common denominator. Well, this has a y times a y minus 5. Sorry, y plus 5. This one has a y plus 5 already in there. This one has a y already in there. I'm good. My domain restriction would be that y cannot equal 0 or negative 5. Then I'm going to solve by either creating this common denominator, so multiplying this one by y over y and this one by y plus 5 over y plus 5, or the full destruction, which is multiplying everything by that lowest common denominator. I'm going to do it in a different color. So I'm going to multiply everything by y times y plus 5. And then what will end up happening is that all my denominators will get destroyed. And then I look to see what I'm left with. And what I'm left with is 3y plus 5, and then y times y plus 4. And then this y plus 1 needs to go in brackets because it needs to get to multiplied by the y plus 5. Then I'm going to simplify. So 3y plus 5. I'm going to distribute the y, so I get y squared plus 4y. And then here, bigger distribution, so y squared plus 5y plus 1y plus 5. And then I'm going to simplify. So I've got y squared plus 7y plus 5 equals y squared plus 6y plus 5. Then I got to figure out what I'm left with. So it looks like I'm left with a quadratic, except when I go to minus the y squared to put them all on one side, it went away. I'm going to also minus the 6y. So I'm left with y plus 5 is equal to 5. To solve a linear equation, you want to get y by itself, so I'm just going to minus the 5 from each side, and I end up with y equals 0. Then always make sure you double check. Y wasn't allowed to be 0. So there are actually no solutions to this equation. In other words, there's not a single value that I can put in for the variable y to make this equation true. All right, last question. If you haven't felt up to it yet, maybe you feel like it now, or maybe you're like, but these keep getting harder, Karen. I don't want to do it. That's cool. Let's do it together. So I'm going to factor first. Out of my denominator, I can do what? Greatest common factor out a 3. I'm left with x plus 2. Then what's going on with this guy? Difference of squares in the denominator. X minus 2, x plus 2. And then over here, it's all good. All right. What is my lowest common denominator? This one's a little different. So I've got the x minus 2 and the x plus 2, but I can't forget about this 3. So my lowest common denominator would be the 3 and the x plus 2 and the x minus 2. This one doesn't have a restriction though, because there's no x with it. So x just can't equal positive and negative 2, right? But that 3 is part of the denominator. So then I'm going to take this, and again, you're either going to multiply this guy by x minus 2 over x minus 2, this one by 3 over 3, and then this one by 3 and x plus 2 to create that common denominator, or you're going to multiply everything by that lowest common denominator. And again, we do this to destroy. So we go boom, 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 boom. And then you look to see what you're left with. Well, I'm left with what I would have done if I was creating that common denominator. I'm left with multiplying the 2 by the x minus 2. I'm left with multiplying the 1 by 3, right? Which isn't actually anything. And then I'm left with multiplying the 4 by a 3 and an x plus 2. So what does that mean? Well, when I go to simplify, I'm going to distribute. And then here, I'm going to do the 4 times 3 is 12, and then multiply it by x plus 2. So over here, I've got 2x minus 1, and over here, I have 12x plus 24. And then I'm left with what kind of equation? Linear. So I'm going to put my x's on one side and my numbers on the other. And I end up with negative 25 is equal to 10x. And I'm going to divide both sides by 10. And I end up with x equals 25 divided by 5 is 5. 10 divided by 5 is 2. So I end up with x equals negative 5 halves or negative 2.5. I do not care. Then I check my restrictions. X couldn't equal positive or negative 2. So I'm assuming that this negative 2.5 is good, unless I made a mistake somewhere in the question. So again, if it doesn't match your domain restriction, it doesn't mean it's necessarily right. You don't know for sure unless you plug it into your equation. So let's just do that quickly. 2 divided by bracket, 3 times negative 2.5 plus 6, unbracket, plus 1 divided by bracket, negative 2.5 squared minus 4, unbracket, gives me negative 0.8 repeating. So if I do that on the other side, 4 divided by bracket, negative 2.5 minus 2, unbracket, equals, I get negative 8 repeating. So that's the best way. The best way to check is to actually plug it in and make sure that it makes your equation true. Good luck. That was a long video.